today's session is on custom tools. I did a session last year on custom tools as well, but I think this is a good time to refresh that as well, and then see where we go from there. I've already also identified a possible follow-on session on this, where I want to get Stefan Tinjelis from MSC involved to present on some of these custom tools, because I don't think we will have time today to go through all of them. And with some of them, I would like to get Stefan involved, as he is responsible for a lot of these tools that you see here. Okay, so if you don't know what I'm talking about, this is the custom tool palette in Apex. The main purpose behind this is to add functionality that users want, but it's not available in Apex yet. Or if there's functionality that is very user specific and there's a few users that will definitely use it, that has also been added. A good example of this is bolt modeling. If you have to model a lot of bolts, this toolbox here will be really beneficial. But if you do not really have bolts in your design, you'll probably either use it in very limited circumstances and in other or never at all. So yes, this is where the custom tools reside. And if you don't have this panel here when you open up Apex, I'll quickly just show you where you can go and find these custom tools. So you go to Options, Application Settings, okay, and then you will see here there's also a scripting and customization. I'll just quickly speak about these. You can trigger scripts when you start up Apex, do specific stuff in the post processor. So here are script triggers if you have script that you want to, for instance, trigger when you open up your Apex database. And then here we have the custom tools. And you can see mine here is all switched on. If you don't see these icons here, it should be, yeah, the most probably the case that these are just not ticked on. As soon as you tick them on and you apply OK, you should see these scripts or icons appear, and then you should have access to all of these scripts. Another thing that I also should mention is this, although this is a button that you see and there's a user interface with it, these are all scripts that is written in Python. You have access to those scripts and you can go and edit them. So just a mention, this is not like a function that you can't edit. The script is totally editable. If you change something in the scripts and you forget to change it back, yeah, it's your responsibility if you edit the script to make sure that you're well aware of what you're doing there. But it's open to the user to go and edit those scripts. You can use those scripts as a starting point for something else. We do have a few clients that have taken a few of these scripts and modified it for their own use. And you can do it. And just to show you where most of you should find these scripts, if you just installed Apex normally, if you go to your documents, you'll see here there's an MSC Apex workspace. This is also the default location where it saves a model if you don't specify location, but there is this custom tools icon, and there you will see your demo tools, common tools, and Apex utils. It's the same as I showed there in the application settings. And if you go into this, you go to attributes, or you can drill down to all of these folders. And if you drill down deep enough, you'll eventually see that we'll end up with a script here. So here we have a script for the specific tool that I have open here now, this point mass tool. So this is the actual point mass script here, and this is the script for the user interface as well. Again, if you're interested in the scripting side of things, we can also do a session on that. I can provide you with some basic PowerPoint material as well to get you started if that's something that you're interested in. So that's also an option, but I just wanted to quickly show you that you actually do have access to these scripts. It's not something that is locked away. You can open it. If I quickly just open one of these in Notepad, you will see that this is a script that's totally editable. And the language that it's written in is Python. So if you want to, you can use this as a starting point and change them as well. The other thing that I should also just mention before we start with demoing some of these tools is if you want to contribute to these tools, the MSC team has a GitHub repository where they maintain these scripts and add functionality. And the plan is that they will open this up to users of the software very soon. And they are in the first round of adding people. But if you're interested in contributing to these scripts or already have some scripts that you think other people might be interested in using, just please contact me and I'll put you in contact with the correct people to get access to that GitHub repository that you can upload your scripts and also contribute to these tools that we have today. Now, a few other things that I just quickly want to show you is, obviously with the scripts, they often have a very specific way of working, and they are not necessarily as robust as the rest of the Apex functions, but they have at least now started to provide some documentation. So as with any other Apex function, if you hover over it, you'll get this pane and you have access to a video and some documentation. And if you see here, we have exactly the same functionality here. I can say learn more, and it will take me to the documentation. You can see here on the side, it actually has all the different Apex utilities included here. If I go to custom tools here, if there's new tools added in every release, they put it under here. So in this release, there was 3 new tools added. Now, the one thing that I should also show you, I just quickly want to go far enough. You can see this says under construction. So there is still a few tools that is missing documentation, but most of the tools that is available today will have documentation. If you drill far down enough, you will see this is the one of the most commonly used bolting tools. It has a description, and you can at least use this to see how this tool works. My experience with this is it definitely helps, but there is some cases where the documentation is not enough. And then the best option would be to contact me, but you can also contact the person responsible for that tool directly. So if you look, you will see every tool that is in this toolbox also has a responsible person for it. So if you run into any issues or would like more information, you can contact this person directly. The only thing that I would ask is that you please CC one of the Simplex team in as well, and we can also stay in the loop. The other thing that has also been added is there is actually some video material available for the custom tools. So there is custom tools and there is videos that will guide you through these as well. Again, some of them are very detailed. Some of them just show enough to get you started. But again, we're moving in the right direction with these tools, and it's really becoming more and more usable with every release that they do. I just quickly want to close this up now. So again, what I will recommend, if you want to use one of these tools, before you use it, just quickly consult the documentation and watch a video just to give you a quick intro to what this tool is meant for. There's also some workflow instructions that you can follow. The one downside to this is because you have different people responsible for the tools. The documentation and the level of detail for every tool may vary a bit. The idea is that a lot of these tools will eventually make their way into Apex. As an example, we can just quickly see, I just want to show a specific example. I think it's, so there's a 3D lug load. And if you open it up, you can see there's a few different distributions that you can do, but you can also see now when you open the loads and boundary conditions, there is also a lug load there. There's the lug load. So I think the only reason why the lug load is still not completely removed is because currently I think they don't support all the distributions that's in the tool. But eventually the idea is if it's a tool that's being used by a lot of the customers, will eventually be removed from this section and it will become one of the Apex standard features that's then maintained by the Apex development team. Okay, so let's just get started. So I want to go through a few of these tools today. My plan is also to do a second follow-up session, specifically talking about all of the bolt tools here. This is more or less a section on its own, or a session on its own. And my plan is I want to combine this with some of these tools as well, the contact and also the export utilities to Mark and Sol 400. I am going to speak to Stefan Tenelius, which wrote a lot of these tools. He is responsible for this whole export utility tool that's here, but there has now been so many iterations of this that it becomes a bit difficult to keep track with what is currently working and what is currently already implemented in Apex. Because if you read the What's New release, you would have seen that there's also now support for nonlinear simulation with the addition of Sol 400. So I'm not exactly sure in terms of the contact modeling, in terms of export utilities, what of these options is still relevant and what options you can do in Apex as is. So my plan is to speak to Stefan with regards to this, and we'll either do a session then on the bolt modeling tool and the export utility as one of these end of the month sessions, or maybe we will do this a bit earlier, maybe in a week or two's time, seeing that we're busy with this whole Apex utility functionality. Okay, so let me now start with demoing. Hopefully everything goes all right. If Murphy steps in somewhere, I apologize, but hopefully everything works as it's supposed to. So this is just a small section of a fuselage. And what I quickly want to demonstrate is a few of these composite tools, just to easily add Ply Stacks. And also there's a few different ways, so I'll just illustrate a few of them. And then I'll go on to another model where I will illustrate a few of the other tools as well. The plan is to illustrate the bulk of these tools within this session. Okay, so the first one is just to add a simple Ply Stack. This tool, how it works, it basically specify the thickness of each ply, and you specify the angles of orientation, and you need to specify material. This tool won't work if you don't have a material specified. In this case, I already have a material specified, obviously, for laminates, you won't specify aluminium or any of these properties. This was just the dummy material that I used to test some of the functionality. You do have the option to specify orthotropic materials, and then you have a lot of different properties that you can add here to specify the correct material model that you need. Another thing with regards to this specific tool, let me just quickly close this, is you already also need to have a panel specified. So let's just quickly do that. So I can just say add a panel, and I will add it to this one. Okay. And now that I have a panel, I can actually go and apply Ply Stack to this specific panel using this utility. So if I say I want to apply, I can just say, okay, I've already specified my thickness and my material and my orientations. And then I can click the specific section where I want to apply this Ply Stack, and I can apply it. And now if we go into this panel, you can see that all of my plies have been created. Obviously, this is not necessarily ideal because you will have different materials for your different sheets that you use, different orientations. So another way of doing this is you can actually go and create a CSV where you specify the material, the angle, and the thickness. We can quickly do that as well. Again, important for this tool to work is you already need to have all the materials that you have in your spreadsheet created here in your materials, and you again also need to have a panel already in place there. I'll just quickly delete this panel and just assign a panel again, and then I'll just quickly demonstrate this with a CSV. So I've already created an Excel spreadsheet that looks more or less like this one. If you want to know the format of the sheet, you can just come and look at this photo. So you just have to have an Excel spreadsheet with material, angle, and thickness headings. And then you need to specify the material, the angle, and then the thickness as well. And it will then apply it in this order on your panel that you specified to. So I can say, okay, I quickly want to get the CSV. This is also something to note for this specific tool. The format that the Excel spreadsheet must be in a CSV. For some of the other tools, again, you can have, there's more Excel formats, but again, just when you want to use these tools, make sure that you have the correct format available. Let me just quickly go to, okay, so I can do this, and then I can click the panel to which I want to apply it, and I can execute it. And again, when we come and look, I can see that all my plies have been created. And this is similarly to what I specified in my CSV file. Now, there's more tools here, so you can again also import sheets. So if you have all of your sheets, you can set up a Excel spreadsheet again with this format, and you can then import all of your sheets. They will come and sit in this sheet stack display window. And then after you've imported all of your sheets that you want to use for your different layups, you can also import different stacks. And then it will, again, create it also in this specific interface here. The only important thing to remember with this one, if you want to import your stacks, you first need to have your sheets imported before you can create your stacks. I really wanted to show this tool today because I think that's also quite a cool tool, but for some other reason, I can't I'm doing something wrong and I'm getting errors. But the idea behind this Composite Designer tool, so it's a pre-processor tool. So there's a few different failure methods already embedded in the tool. If I can just quickly open the interface, so there's a few different failure methods, and then you can specify the different failure theories. The only requirement here is you can see here it wants you to have 2D elements. So you need to first mesh this geometry here, and then you can either select a single element or multiple elements. And what you will get then is you will get a plot that looks similar to this. And you can then go and play around with your ply orientations and thicknesses, and this then will update accordingly. So you can use this as a type of a design tool to make sure that your material strength of your composite is similar to what you want in your design before you go through with an actual simulation where you then go and evaluate the stresses afterwards. Like I said, I wanted to demo this tool, but I keep on getting an error that I could not get resolved before this webinar. Then a few other tools in this palette that is also quite nice is this materials tool. So this has a few predefined materials, and it's actually just a spreadsheet at the back end. So this is a spreadsheet with values filled in. You can go and set up your own spreadsheet as long as it's in this format. You can set it up, and you can use this tool to go and edit it and import it as materials. So this is a nice way if you don't have access to something like Material Center, but you still want everybody to use the same material properties. This is a quite convenient way where you have a spreadsheet. Where that spreadsheet is located is at this specific location on my computer. But if you have like a general spreadsheet that you want everybody to use, as long as the location is specified here and it's in the correct format, you can then just say, okay, please import all of these tools. This is typically a script that you can also go and run at the start of every Apex session. And you will now see that all of those materials that was created within that spreadsheet is available here in my materials to use and assign. The other options there is just a few other options in terms of you can also create your materials from PDF. This specific tool is very much similar to this section tool. So you can, if you assigned sections to your model, you can go over to the section view, and it will show you all of the different sections or even different panels in this section view. So it makes it easy for you to see which section is applied where. And the idea is that eventually you will have something similar for the material, but in the meanwhile, you have this option here to see which materials is assigned where. If you have a structure with single material, obviously this won't have any use, but just know that it's here. The other thing that I want to quickly show you as well is to map pressures and also to display pressure contours, because that's something that you cannot do currently in Apex. For that, I'll quickly just switch over to another model. So this is a simple model of a glider. I've already meshed this model of the glider. If we quickly just go and have a look inside this, you can see I can say select target, and I can select this specific item here. I just quickly want to see. I still need to browse for whatever I want to map. So here is a few different ways of how you can map pressure. In my case, I used Cradle's XML format to map this. So here in the post processor, I can just quickly switch off the contour plot. You can see there is my result, or there is my glider that I simulated. It's not that clear now, but it's just orientation. But in any case, the results I extracted from a CFD run that I did on this glider. It's just a simple incoming wind, and then I can map the pressures and temperatures from here to Apex. To get to this specific format, I'll be more than willing to show you to extract that XML format correctly if you want to map pressures from, say, for instance, a Cradle to your Apex model. I will easily show that to you. And then if there's any of the other methods that is also of interest, I'll show that to you as well. I'll just quickly go and select the correct file here. So that's the file that I've created. So I'll say, okay, I've selected my target, I've specified, so I can now just wants me to select it again because I've now specified a material. Now what I can do is I can preview this as well. This usually just takes a while to do it, but I'll quickly show you. It doesn't take that long. Just give it a few minutes to get that done and dusted. And then I'll quickly just show you the final result. Okay, so the one thing is this pops up in a separate window, but you can see there my pressures have been mapped now to my glider. If we open up the preprocessor, we can go and see that these values that we see here and the values that we see in Apex should be the same. So you can go and preview it before you apply the load, and then I can say create the load. I'm not going to do that now. That takes quite a bit of time, but eventually you will see once it's done, you will have a pressure load here that's a distributed pressure that resembles the specific load that we just previewed. Again, if you want to preview this later on, you can just say display spatial load, and you go and select the load that you want to preview, and you execute, and then it will display the pressure distributions in the same way as I just illustrated here. There will be a window that pops up, and you can then display it. Okay, there's one last tool that I want to show in this, and this is this point mass from solid. So if you have any type of solid that you do not want to represent in full detail, but you want to at least take into account the mass of the solid, this tool will go and create a point with the correct mass at the centroid or a center of gravity for that specific component that you select. Again, what's important here is you need to specify your material, and for it to be able to calculate the mass, you need to specify density value as well. So I'll just say quickly assign a material to this part here. And if I now just say point to mass and I apply, you will often also get this log, and you can go and see messages in this log. Often the information that you get from the tool will be displayed in this log file, but it just says it successfully created a point mass for the object that I've selected. We can quickly say, let's hide this, and you can see there is my point mass. And then what I can do from here is I can obviously use something like a discrete die to go and tie this point to all of the relevant areas that it needs to be tied to. I'm not going to do that now, but obviously you get the idea behind it. So again, in this type of model, that's really convenient. The other thing that I should just mention again as well, it can only use the data that you provided. So if the center of mass is not at the correct location, that is possible because it only uses the geometry itself to determine that location. And if your CAD is not an accurate representation of what is actually being modeled, or what is actually in reality, then obviously your mass and your center of gravity will be in the wrong location. Obviously, you can just go and move this to the correct location if it's in the incorrect location with the transform tool. But yeah, the idea is to make these type of operations where you have a lot of things that you're not necessarily interested in modeling, make it possible to do that. Okay, so then the next section is on this bolt modeling section. Now, like I said, I don't think I will have time today to go through all of these, and we'll do this in a separate session, but I will just show you one of the bolt modeling tools that most of us are familiar with and uses. So this tool, basically what it does, it will go and identify holes. It can be solid geometry, it can be surfaces, it can detect both, and it will go and identify holes and see if there is any adjacent holes to that specific hole, and it will then go and create a connector between those holes automatically. Now there you can give it a name. Let's just say test, and you can then decide if the type of the distribution, the fastener type, if it's a flexible link or a rigid link. And you also need to specify material for the beam elements that it will insert. And then this is also the important part, is where you specify the diameters. Now, the diameter that you specify here is based on your units that you use in the model. In this specific model, I'm using millimeters. So if you want to use this tool, you just need to have a good idea of the sizes of the holes that you're dealing with. So I'll just quickly measure this, and that's 19 millimeters. You can obviously make it a bit bigger just to ensure that that hole is captured accurately. So if we, for instance, just say, I don't really care about the minimum diameter, but I at least want to say I want to look at all holes that is smaller than 25 millimeters. Now, if I do it like this, where I just say, okay, go, it will go through the whole model, and it will go and look for holes that is smaller than 25 millimeters. Now, if that's the intention, that's an easy way to do this, but you can also go and select different components that it should interrogate, and it will then go and create the required connections. I just quickly wanted to finish up here because I want to show something specific here, because from the results that we will see here, it will look as if the bolt tool doesn't really work as it's supposed to, but I'll show you why it did not create bolted connections for all of these different connections. So you can see it has now created connections, but the only place where it actually did create these connections is here. If we switch off the solid, you can see it identified a lot more holes, but it didn't create connections for a lot of them. And the question is there an issue with the bolt modeling tool, or is there an issue with the model itself? And if you now go and look here, you will see it's not that easy to show, but in most of the cases where there isn't connectors created, there is some type of misalignment that occurred and it could not create the connector. But if you have proper CAD geometry, it should not have any issue creating these connectors. But that's just something that I would like to mention, is just before you execute this tool, make sure that your geometry is also correct. So meaning that your fasteners and everything that you want to represent, that those all matches up, because if there's misalignment, chances are that those connectors won't be created. Obviously, you can go and create them afterwards, but the idea is that you will save time creating them in this fashion. The other thing that I should also just mention is if you use surfaces to represent your holes, you should make sure that there's only one vertex representing that hole. Often when you import CAD, they tend to represent it with two vertices. So it will typically have one vertex at the bottom and one vertex at the top. In that case, you just need to use your cleanup tools, something like add remove vertices, so that it can remove redundant vertices, and then you apply the tool afterwards. So it's always a good idea to first do your CAD cleanup, and then after that you can proceed with the bolt modeling tool. Okay, like I said, there's quite a few additional bolt modeling tools. Stefan also touched on specifically identify bolt and then create fastener or create bolts from fastener curves. And he also specifically touched on this one where you create 3D bolts from fastener curves. Like I said, I want to do a separate session on the bolt modeling and then also on the utilities application. Okay, so let's quickly move on to the next one. I'll quickly just, for this, I'll actually just require a clean database because I want to demonstrate most of these tools just on a simple plate. Okay, just give it time. Okay, so if we go back to this, so these tools that you have here, most of the Patran users will recognize a lot of this. These tools are functions that's really common in Patran, but it's not here in Apex. Something simple like creating a surface just by specifying coordinates. So I'll just quickly use this tool to create a surface for me. Obviously, I can't see it here. You can just click on this and it will fit the view. And then I just quickly want to create a mesh on this. That's only 1 millimeter by 1 millimeter. So we'll just do 0.5 millimeters so that we actually have a few elements to work with here. Okay, so some of these tools is simple node offset, so node move operations, offset tools. So for instance, the thing that I want to show here is what's important. If you want to offset a node or use any of these node tools, you first need to go and select the node that you want to move, and then you need to say get IDs. This is a script that then runs and gets the ID of that node. And now I can say, for instance, want to set offset this by 10 millimeters. And if I do that, you'll see that that node has been offset by 10 millimeters. The other node operation tools works very similarly. If I want to update the coordinate, I again need to just come and select the node that I want to update the coordinates of. I need to get the node ID, and I can, for instance, say, let's make this coordinate 0, 0, 0. And if I do that, then it moves that node to that. So these are just simple operations that you can do if you want to create a node. That's also very easy. So very simple operations, but it can definitely be quite convenient to do. I think that's just out of screen. There is that node that I've created. Then some of the other tools is something simple like interpolating between 2 points. So if I, for instance, just want to create one tool, often you'll see, okay, I'm hovering. I know there's something there, but it doesn't select it. Use these selection tools to narrow that down. So now that I've said I want to select a node, I know there's a node there. So I can just go and select them both. For instance, let me just quickly. The important thing for this tool is you need to keep in control when you select your nodes. Otherwise, it will select the one and then lose that information when selecting the second one. And I can just, and you can see there's my node in the middle. This is also a nice thing is if you have a complex geometry and you don't know anymore which surfaces are stitched and which are not stitched, this is a convenient tool. I just quickly want to open up this to show you. So from this geometry actually looks quite nice, and I think everything is solid. But as soon as I switch it off, I see, okay, this is no longer a solid. These are all surfaces, but it's quite difficult to see why this thing is not a solid. And then this tool is quite convenient just to identify the 3 edges, so it will go and label it. So if I say label 3 edges, you can see it will now go and label all of these edges, and it makes it easier for me to go and identify these problematic areas for the specific, and then I can at least know where I should start to go and have a look. I just quickly want to pop back to, just go back to the simple. You can actually see also 3 edges when you use different tools. You can see this is also a 3 edge because it's colored red, but it's not that obvious and easy to see. So that's the whole idea behind that tool. Then there's simple tools like Disassociate Mesh. So I can just click the mesh that I want to disassociate, and I can run this tool. And if I go and delete that surface, we should see that there's still a mesh there. This is just a simple copy tool. So I can just say select, and I want to copy one, a distance of 10 millimeters, and I want to do it in direction just 1, and I want to do it distance of 10. And I can just then say, please create a copy. And I can see there is my copy of my surface. Often I have tested it, and in some cases it copies the mesh and everything with it, but it seems like in this case, it actually did not do that. Then just another tool that I specifically want to show here is this remove duplicates. So it is possible in Apex to create 2 surfaces on top of one another. And this can be really irritating because it's difficult to find them. And you can use this remove duplicate tool to make it easier to get rid of those surfaces. So if I just quickly make a copy of this surface, let's just move it up, say 10 millimeters. And then I'll just move this one up 10 millimeters as well. And now we should sit. Okay, let me just quickly close this now. So now we will have, you can see there's a surface and there's a surface. So we essentially have a duplicate surface there. And if I now say remove duplicates and I just select the surfaces, you can see that I again now only have one duplicate. Collapse vertices, very plain and simple. If you have vertices close to one another and you want to collapse it, it's very similar almost to equivalencing your mesh. I'm not going to show it because I see we are running out of time fast. But again, just go and look through these tools. This is also a nice tool if you want to join different meshes with ties or with an auto tie. Then it will go and you just select the edges where you have meshes that has different sizes, and you select the curves where the meshes does not tie up, and it will automatically go and create the required ties between the nodes if you want to use it like that. Then just quickly on some of these last tool sets, I'll just quickly do some of the query tools as well. This again is mostly very straightforward type of tools. So for instance, if I want to have the location of a specific point, for instance, let me just get this correct. So for instance, if I want the location of that point, I can say just I want it in millimeters. In this case, I actually need to go and look in the log file for that information. I have similar options to get solid data for surface data, and it will typically give me stuff like area, my circumference, stuff like that, centroids, and so on. Similarly, with curves, I can do the same. This is also quite a nice tool. So if I have a mesh and I want to identify the element with the shortest length, this is typically something that is of interest for, say, Diatran users, where your element length is dependent on your smallest edge length. The time step is dependent on that. This can be quite a nice tool where you can just select the mesh and you apply it, and it will identify for you the elements. It will tell you what type of element it is, what's the shortest edge length, and you at least will have an idea, should I go and refine my mesh a bit more? What should I do to get rid of this? Here you can also, if you want to extract specific data from elements, you can use this and it will label it. It's very similar to the attributes tool or show attributes tool in Patron. This is again simple count nodes and elements. So I can just select this and I can see I have what try elements, how many nodes. Again, this is something that I can also do with other ways in Apex if I want to count the number of nodes, but this is just convenient to do it. Like for instance, count by part, count by selected and ID ranges. That's very convenient. I think this is typically an example of a tool that's redundant. It will just show you the model name and where it's located. This information you can get here. Here is your model name. How we usually did it, if we wanted to know where we saved our model, we would just say save the model, and we will see again where we saved it and what the model name is as well. This is also a very nice tool if you have a big assembly and you've moved parts around and you just want to clean up your model a bit. You can quickly remove empty parts and so on. So this is definitely just a nice tool to clean up. I haven't used these automated reports, but there is a possibility what these reports will do. It will extract some information for you automatically from your model, and you can customize that report as well. Then just lastly, quickly, I want to just talk a bit about this last tool or tool pane. Probably the most interesting one here is this import Apex. So for instance, if I just take this small model, I just quickly want to find out where this is saved and what model it is. Okay, it's saved there in its model 5. So say, for instance, I want to import it into this model. I just say import Apex. And now I just need to browse to the folder where that model that I want to import is located. So I know it's documents and it's in my Apex workspace, and I know it is model 5. And I say, okay. Okay, I think I did something wrong now. Oh, that's also the issue. I can go and read the error, but I'm pretty sure it will complain because it says this model is still in use, so it can't import it. So we'll just quickly close this model and we'll do the operation again, and hopefully everything will work as it should. So let's just quickly go again to documents. MSC workspace, and then model 5. And we can see it's now taking a bit longer, so I expect that this thing is busy working. And there I have my model. This is similar to what you have in Patron, where you can import a model either into an existing model or just into an empty database. There is a few other tools here if you want to create specific studies. You can go and name these studies and add different events. And when you exit or say add event, it will create the study and the number of events here. So the nice thing about this is you can actually name your events. Whereas if you just create the study normally, Apex will automatically use the conventional naming method here. Of a static scenario with one event in there. This is convenient when you want to import your model into Mark. So this one will just export a normal DAT file, and then you can import it into Mark. And this one will actually export your Apex model and import it into Mark already and create a .mud file that you can open up, and everything should already be there. It's supposed to take over all the information that's stored in the PDF, as well as the geometry that's in here as well. It will also import that into the model.